No.
So it's just like shift cos, similar to that with your calculator. So if you put in shift cos of -1 in your calculator, you should get 180 degrees. And basically, when the y coordinate is -1 on cos, the x coordinate is 180 degrees. That's where it comes from.
Okay. Yeah, okay.
Maybe just try radians arc cos -1/2.
Radians cos -1 -1/2 is 2/3 pi.
Yep. 2/3 pi. That's fine. Those anything like that can just go into your calculator. How would you do 5b?
Shift sign. X equals shift sign pi over 6.
So arc sine is similar to shift sign.
Yeah.
What would get rid of arc sine?
Sine.
Yep. Do sine to both sides.
So sine pi over 6.
Yeah. And what do you get there?
And radians or degrees?
What do you think? Yeah.
Radians. Sine pi 6/2.
Yeah. Okay. I think you're good for that. And so on the arc sine graph, when the y coordinate is pi over 6, the x coordinate is 1/2. Y equals sine x. Is it a function? Do you know what a function is?
Is it like, well, in the booklet it was like 1-to-1 or many-to-1.
Yeah.
So sine x is many-to-1?
So if it's a function, it doesn't have the same y coordinate twice. Now y coordinate would repeat.
Oh, okay, so it's not a function.
So it's not a function. Between what two x values would it become a function? Would it not repeat? So what domain would make it a function?
0 to 180.
Yeah, so that would be half of it. So 0 for sine? No, I think that would come back down at 180, doesn't it?
0. Oh, so 0 to 90.
So 0 to 90. What would be the range for that from 0 to 90?
X is
Range.
less than or equal to, y is less than or equal to 1.
So between 0 and 1?
Yeah.
So from 0 to 90.
0 less, no. Oh, how do you write it? 0 less than or
Yeah.
y less than or equal to 1.
Yeah. But the sine graph itself goes down to -1. So how could you have a different range so that it would, a different domain so that it would have the full range? What domain would give you the full range from -1 to 1?
360.
So that would repeat. So
you don't want the y values to repeat, but you do want
you do want the full range from -1 to 1.
But you don't want the y values to repeat.
Yeah.
So you want the values to. How can you do that? Oh wait, hang on. So from -pi/2 to pi/2?
Correct. And that's the normal domain and range. And in fact, it'd be any You could also do from pi over 2 to 3 pi over 2, but the normal way is to just take it as minus pi over 2 to pi over 2. And that would be a function. So what range does it give? Minus 1, 2, 1. Okay. The inverse function of sine is called arcsine x. Do you already know about inverse functions? Anything you already know about them?
No, I don't think so.
Okay. Inverse function is it's a reflection in the line y equals x.
Inverse function is reflection in the line.
I think last time, do you remember we would, to find the inverse function, we would swap the x with the y?
Yeah.
Yeah, so the x coordinate of the function is the y coordinate of the inverse function, and the y coordinate of the function is the x coordinate of the inverse function. So, how about this one? What would you do here?
So if y equals sine x, when it says contains 1 over 6 pi, does that mean x is 1 over 6 pi?
Yeah, so like this is on the sine graph, 1 over 6 pi and a half.
So then we do 1 over 6 pi equals sine x. Oh wait, what is the corresponding point on y equals arc sine x? So we substitute the x, so we get 1 over 6 equals arc sine x.
What did we say about a function and inverse function?
The x coordinate of the function is the y inverse.
Yeah. So where is the corresponding point on the inverse? Arc sine x is the inverse function of sine x.
Is the y coordinate. So 1 over 6 equals 1.
Sorry?
So arc sine x equals 1 over 6.
Just the coordinates of the point.
Oh, is that a coordinate? Oh. Oh, it's a coordinate. Okay. So the x coordinate is the y coordinate. So if the x coordinate was 1 over 6 pi, so then, oh wait, hang on. You just swap them around?
Yep.
So half 1 over 6 pi?
Yep. That's all there is to it. Okay, y equals sine x. This is the domain and range that makes it a function. Y equals arc sine x. What's its domain? What's its range?
Domain is just it's just y. So is the range what the domain is for y sine x?
Yeah.
So the range is minus pi over 2, less than or equal to, no, greater than or equal to, yeah, that one. And domain is just the range.
Go on.
Is the domain the range?
And what is it?
Oh, x is greater than or equal to minus pi.
So x is between
Yeah.
minus 1 and 1. And what goes down here?
Y?
Yeah, so I was just checking that. Yeah, so domain is the x, range is the y, and they just swap for the function and inverse function. Okay, let's try these ones.
Oh, we have this. Okay, so cos it's greater than or equal to 0, so cos 0 is is 1. So y is greater than or equal to 1. And cos
So what's the range for cos?
Y is greater than or equal to -1,
Yeah,
less than or equal to 1.
yeah.
That makes the domain x is greater than or equal to -1.
Between 1 and -1.
Yes.
And range?
It'll be y is less than or equal to pi,
Yeah.
greater than or equal to 0.
Okay, same thing, tan. Any idea how you'd write the range for tan? So not arctan, just tan.
You can't do pi over 2.
So y is tan x. So what y coordinates can you possibly get for y equals tan x? Possible y coordinates for y equals tan x.
I was going to calculate and do it. So that's that. X equals.
Just by looking at the graph. Possible y coordinates for y equals tan x?
I don't know what that goes up to 1.
Goes up to infinity.
Oh, okay. Infinity.
What would it go down to?
Infinity.
Yeah. So
Minus infinity.
yeah. And so basically the way we say that is y is an element of the real numbers, and it just means y is any real number.
Okay.
Okay. Domain and range for arctan x.
So x is any real number. Then y is less than or equal to pi over 2. Greater than or equal to minus pi over 2.
That's it. Okay. Good stuff. These ones you would just put into your calculator. They're just numbers. Just numbers. Okay. How about this one?
Cos 60 equals 0.5. Find the solution for cos x equals 0.5. So, okay. Is that like a process, or do I just... No.
How do you find a second answer for cosine?
Arc.
So if you do shift cos for 0.5, calculator will give you 60. Is there any other angle?
Shift cos 0.5. Because... yeah. Cos 60 equals 0.
So basically x equals 60. Is there any other answer you can get? Do you know how to get a second answer for cosine?
Also, I can't remember the graph. Is that the one that looks like a U?
Yeah.
So do you add 180?
360 minus first answer.
360 minus 60.
Yeah.
So that's the first one. the second one is minus 360. Why do you... Is 360 minus first answer the same as 270 plus?
No,
Oh,
270 plus 60 wouldn't be the same thing. So 360 minus 60?
oh yeah, of course it would be. 300.
Yeah. And so that's 300 there.
Where's 360 on that graph?
So this is the cos graph from 0 to 360. And so
Just 360 is 1.
it's symmetrical about 180. And so 60 in from the right is the same as 60 in from the left.
Okay.
Or 60 in from the left, same as 60 in from the right. Put in cos 300 into calculator, see if you get a half.
Yeah.
Yeah. So basically this graph is going to go on forever. You're going to get an infinite number of answers. Cos 300, so there's an infinite number of solutions, but 60 is called the principal value because it's closest to 0. That's the one your calculator will give you. What answer will you get here?
Arc sine 30. So... Do the signs cancel out, or is that not a thing?
Yeah,
With 30.
30. That's it. How about this one?
Is that the same thing?
Put it into calculator, see what you get.
5 minus 1 sine in degrees or radians. 80. Wow.
Why are we getting 80?
Not too sure, to be honest.
It's because sine 100 equals sine 80 in the same way that the cos 60 equals cos 300. It's just that the 80 is the principal value because that's the one closest to 0. And so that's just something to watch for in your answers. If you get something that's a bit weird, just check that it's you might have gotten a second answer as opposed to the principal answer, the first answer. Okay, how about this one?
Sine minus 1, 2, which is not a real root.
Why is that?
I don't know.
What does the sine graph go up to?
Oh, 1.
Yeah, so there's no x value that will give you a y of 2. Okay, how would you solve this one?
Arc sine x, so to get rid of the arc sine, you do sine of pi over 3. So sine and degrees or radians, obviously. Root 3 over 2.
Root 3 over 2. Root 3 over 2. What is arc sine x? So arc sine x equals 2 pi over 3. Solve for x.
Was it going to be the same? Yeah.
So actually there should be no solutions, and that's because earlier we said for sine to be a function it has to be between a certain domain, and so for arc sine its domain is, its range is between minus pi over 2 and pi over 2. And so that's just, it's similar to the sine thing. It's just something to be aware of, that when you reduce it down to a function, it will have fewer solutions. And so you just have to be aware of that domain and range. Okay, this stuff you're fine. I'm gonna go to the next thing. I already have it downloaded. 5A. Okay, let's see. Yes. Using the diagrams or otherwise, what are each of the following? So, what are each of these?
Using the diagrams,
Yeah.
so 0 degrees in radians is 0 times 180 over pi.
What would be sine 30 degrees using the triangles?
Why do I need to use the triangles? Can't I put it in my calculator?
You won't always get an exact figure.
Okay. Which triangle do I look at?
Sine 30?
Sine. Half.
And sine is opposite over hypotenuse, and you can see 30. Opposite is 1, hypotenuse is 2, 1 over 2, a half. How about cos 45?
So look at adjacent over hypotenuse. A half.
So that would be 45 degrees in this triangle.
Oh, 45. Oh, okay. So adjacent is 1. Hypotenuse is root 2. So 1 over root 2.
And how about the tan of 60?
60 is there. So adjacent of 60 is 1. Toa, so it's Toa, so opposite over hypotenuse. So 2.
2 is okay.
Opposite. Oh, wait. Opposite over adjacent. So opposite is root 3. Adjacent is 1. So root 3.
Yeah, root 3 over 1 or just root 3. Okay, so that's where these exact trig values come from. And you can also use the diagram like the sine of 180 is 0, that type of thing. Sine x equals opposite over hypotenuse. What is 1 over sine x?
1 over opposite over hypotenuse.
Simplify. Keep, change, flip.
1 over opposite is just hypotenuse over opposite.
And that's because sine x is the same as sine x over 1. So 1 over sine x. How about this one? Next two.
Okay, is it? So hypotenuse over adjacent.
Last one.
Adjacent over opposite.
Yep. Sine 60 root 3 over 2. 1 over sine 60.
2 over root 3.
Yep. And if you put it into your calculator will automatically rationalize the denominator. So it will say 2 root 3 over 3 because it multiplied the top and bottom by root 3. Tan 60 we found earlier, actually. We said it was root 3 over 1 or just root 3. 1 over tan 60.
1 over root 3.
Yep, and it rationalizes the denominator in your calculator to root 3 over 3. So you haven't seen secant, cosecant, cotan in school? Okay, so this is what these things are called. So in GCSE, for the first time, or Key Stage 3, you saw sine, cos, tan. Now you're seeing when you have the hypotenuse over the opposite, which is just 1 over sine x, that's called cosecant x. And that you can always just look at the third letter. So cosecant matches up with 1 over sine x. Third letter here, secant matches up with cos, and cotan matches up with tan. Okay, put them in the right place. Cosec x, where does that go?
Cosec x is 1 over sine x, so 1.
No, just middle one, that's fine.
Oh,
Sec x,
left,
yeah. Cot x,
right, far right,
cosecant,
middle,
cotangent,
right,
secant,
left.
hypotenuse over adjacent,
So it would be after that would be cosec. No, sec.
yeah. Hypotenuse over opposite,
Middle cosec.
adjacent over opposite, yeah. And so, oops, you're going to see these words written different ways.
So what's the difference between cosecant and cosec?
It's like the difference between cos and cosine, just a shorter way of saying it.
Oh.
It's just because students can't even say any stuff. They're like saying like sin x and all this right until the very end. Okay, B1 part A, try it.
When x equals pi over 4, what is the value of cos x? So cos pi over 4.
Mm-hmm.
Radians. Cos pi, no. Pi over 4. Root 2 over 2.
Okay. And B?
When x equals pi over 4, so what's the value of sec x when x equals pi over 4? 1 over cos pi over 4.
Okay.
You said that was it wrong?
Sorry?
You said that as if it's wrong. Was it wrong?
Did you say 1 over cos pi over 4?
Yeah.
Yeah.
Root 2.
And so basically, if secant x is 1 over cos x, then it will be 1 over root 2 over 2, which is the same as 2 over root 2. Your calculator just rationalized the denominator. So basically, if you have to find sec x, or let's say sec pi over 4, you can find cos pi over 4 and flip the fraction.
Oh, okay.
And it says root 2 because it rationalized the denominator. So to find the exact value of a reciprocal function of the form sec x, cosec x, or cot x, put the corresponding sine, cos, or tan into your calculator, invert the fraction, and rationalize the denominator. But your calculator will do that. Let's see. Okay, how would you do 1a?
Do cos of 23 and then just flip it.
So what do you get?
So, oh, hang on, I need to go into degrees. Oh, that's so annoying.
Or you can just do 1 over cos 23, that would work in one go.
Oh, yeah. You're right. 1 over cos 23 gives us 1.08.
Yeah, 2 decimal places. How about 2a? No, let's do 2c.
Is it just 1 over cos 150?
Yeah.
Minus 2 root 3 over 3.
3 over 3. And then you're doing the same thing but in radians, doing the same thing but in radians. I'm happy there. X a half tick. I can find the exact value of a reciprocal trig function. Okay, tan theta equals 2. What quadrant is the angle in? Any idea what this is about?
Which quadrant that tan theta equals 2?
This is your cast diagram that you mentioned before.
I've mentioned before.
I thought you said it at the start, so.
No, we didn't learn that. I learned that by myself, but we didn't actually learn that in college. Apparently it's really confusing this way.
It is pretty confusing. Hang on, page 20. Let me just go back to this one. Let's see if this is the right one. I think it might be at the other one. Yeah. So if I go back to the very start. So I just glossed over it. You see how if you look at all three graphs, I've got sine x and cos x. If you look at the tan x as well graph, basically between 0 and 90, sine x is positive, cos x is also positive, it's above the line, and tan x will also be positive. Between 90 and 180, cos x is the only one that's negative. Yes. Then between... No, I'll have to refresh. Sorry. So you can see sine x is positive between 0 and 180, negative between 180 and 360. Cos x is positive between 0 and 90 and 270 and 360. It's negative between 90 and 270. And then if I had the tan x, you could see where that's positive and where that's negative as well. And to summarize that information, if this is 0, going to the right is 0, so it starts from 0 and it turns clockwise, and if you turn this into degrees, if it makes it a bit simpler for you, so instead of pi over 2 it's 90 degrees. They're all positive from 0 to 90. Only sine is positive between 90 and 180. Only tan is positive between 180 and 270, and only cos is positive between 270 and 360. So using that, you're told tan theta is positive 2. Which quadrant could the angle be in?
The tangent was the 2.
So it's either in here or
Positive.
or all positive. What is theta if tan theta is 2? How would you solve for theta?
Blue. It's 63.4, isn't it?
So 63.4. And how do you get an additional answer for tan, do you know? For 360 we had to do, sorry, for cos we had to do 360 minus. For tan?
Uh, 180 plus.
Correct. And so 180 plus our first answer, what do you get?
243.4.
So 63 and 243. So the 63 is in the all positive, or it could be 243 degrees. and that's in the tan only positive one. So those are the two possibilities there. Any questions about that?
No.
It's just that we don't know which one it is. We know that it gives us 2, but we don't know which of those 2 that it is. And we're told it's between 0 and 360. Here's where this thing comes from. Yeah, so you can see if you put the 3 graphs together, tan is negative between 90 and 180, and that's why tan on the diagram is negative between. So this cast diagram, it's called, is just a summary of where each graph is positive and negative in just one simple diagram. That's all it is.
Okay.
Okay. So these, will they give you, what quadrant will each be in? And will it, if you put it into your calculator, will you get a positive answer or a negative answer?
Sine 30 is a half, which is positive.
Yeah, so 30 degrees is between 0 and 90, so all positive. Yeah. Can you do it without the calculator?
No.
You
Cos
can.
150. Not in my head, no. Or looking at graph.
The diagram.
What diagram? This one.
Yeah. So the cos of 150, which quadrant will 150 be in?
How do you know?
Is it between 0 and 90, 90 and 180, 180 and 270, 270 and 360? Zero to 90?
How do you know that?
Is 150 between 0 and 90?
No.
Is it between 90 and 180?
Yeah.
Yes. And so will it give you a positive answer or a negative answer, cos of 150?
Negative.
Yeah, only signs positive here. And if you want, you can check by putting cos 150 in
Oh,
the
okay.
calculator.
Okay, no,
And
got it.
And you'll get a negative. And by 150, it's literally, here's an angle, here's a 90 degree angle, and so it goes to about there, 150 degrees.
Yeah. Okay.
So
So
yeah. Okay, sine 300.
from 270 to 360, well to 0.
Yeah.
So it'd be negative.
So that is negative. And tan of minus 45, how does that work?
From short minus.
That means it would spin the other way.
With what?
That means it would like turn the other way, like that.
Oh, okay. So that's negative.
So that's going to be negative, yeah. That's it, that's what we got. Okay. Cot 55.
So 1 over tan 55.
Yeah, so this will follow the same thing as tan. Because
Okay.
if one fraction is negative and you flip it, it's still going to be negative.
So it'd be positive.
Yeah,
Positive.
yeah, positive.
Positive.
Go on.
That is cosine 225. So it would be from 180 to 270, and then it'd be negative.
Yep.
Cosec 100. Sine positive, so it'd be positive.
Well done.
Tangent positive, so it'd be positive.
Yeah, tan positive, positive. Well done. Any questions there?
Positive.
Oh, sorry. Why did I put it?
Nope.
Yep, that's it. Okay, radians.
Okay. So I don't know these off my head. Am I allowed to use a calculator or not?
Try to not use a calculator. So a quarter pi.
Okay, a pi is 180, so quarter pi would be 60? No, 180 divided by 4, which is
It doesn't really matter. Is a quarter between 0 and a half and 1?
Oh, you changed the things as well. Okay, okay. Okay, so 0.5. It's going to be all positive, isn't it?
Yeah.
2 pi over 3 is tangent positive.
2/3.
2/3. Half, 1. Sign positive, so it's negative.
Yeah. 4/3.
4/3 is tan positive, so it's positive. 3/4 is cosine positive.
-3/4 might be cosine positive. This would 3/2 is 1.5.
One half. 3/4 is what? Okay, that's a half.
Replace pi with 1 in both the diagram and the thing.
Oh god. So 3/4 is sine positive.
Yeah. And so is that positive or negative?
Positive.
Yeah, because cosec is 1 over sine. Got it. Okay. Tan theta equals 2. Find exact values for the following. How do we do this? Try. How do we do this?
Well, it's 1 over tan 2, isn't it?
Yes. And so, what is the answer for A? Have to plug this in.
28.6.
Exact value for part A.
How do I get it doesn't give me an exact value, just gave me decimal.
Tan theta is 2. Cot is 1 over tan theta.
Yeah. 1 over tan 2.
Nope.
It hasn't given me an exact value.
Tan theta is 2 over 1.
Oh, so... no. Wait, hang on, okay. Tan theta is 2...
And so cot theta?
1 over tan 2.
Nope. It's 1 over tan. 1 over tan theta.
Oh, so half times...
Yes, a half. How do we do B? I doubt you'll get it.
Okay, so sec is 1 over cos theta.
Yeah, you're not going to get it. Tan theta is 2 over 1. Yeah?
Yeah.
What is tan in terms of SOHCAHTOA?
Opposite over adjacent.
Opposite over adjacent. What type of triangle is that for?
Right angle.
Yep. So I'm just going to pick this one down here to be theta. The opposite is 2. The adjacent is 1. What's the hypotenuse? And then use that to get secant and cosec. I'm just going to plug this in 1 second.
Okay, so 2 squared is 4, 5. Root 5. Root 5 is our hypotenuse. Yeah? Two squared plus 1 squared is 4 plus 1, which is 5. 5 squared.
I'm just going to move this laptop. That thing doesn't seem to be working.
A squared plus B squared plus C squared plus 5 squared.
Hi, Saba.
Hi.
Did you get answers for that?
So hypotenuse equals 5.
Root 5?
Yeah.
Okay.
And then what do you do after that?
So what is secant?
So 1 over hypotenuse equals 5 causes adjacent over hypotenuse to be adjacent over root 5.
And so what is what is secant then?
1 over root 5?
Yes. 1 over root 5. And cosecant?
A sine is opposite over hypotenuse. Opposite is 2. And the other one is 1. So cosecant would be a half.
So opposite over hypotenuse, and so hypotenuse over opposite.
Oh shoot, or hypotenuse. So opposite over hypotenuse is 2 over root 5. Root 5 over 2.
Root 5 over 2. We said my battery might die, by the way, so I might have to move. But let's see. We said that tan theta is 2, and we said that could be either in this quadrant or in this quadrant, and we weren't sure which one. If it's in the top right one, they're all positive. What if it's in the bottom left one? To our two answers for secant and cosecant.
Cosecant and sec would be negative.
That's right, and we're not sure which quadrant it's in, so it's either plus or minus root 5 over 2 or plus or minus 1 over root 5. And so to get an exact value, so to get an approximate value, use your calculator. To get an exact value, you have to go back to SOHCAHTOA The tan of theta is 2, which is 2 over 1. Opposite over adjacent, opposite is 2, adjacent is 1. Calculate the hypotenuse and then use the triangle to get sine, cos, cosecant, secant, and you have to go back to your cast diagram to say, well, they'll either be positive or negative. The cos and the sine will be positive or negative, and then tan will be positive. Any questions there?
No.
Okay. And if my computer suddenly dies, please accept my apologies. So let's say 6 part A. How would you do this?
Given that cos x equals minus 5 over 13 and that 90 degrees x is greater than 90 and less than 180, find without using the value of sine x. So cos x equals minus 5 over 13. Do we need the cast diagram?
Sure. So that's what it looks like.
Okay,
And
so
they told us x is between 90 and 180.
So that's, where do the numbers go? From A, it says that just A, all positive. And which way does it go?
Say it again, sorry?
Which way does it go? 0.
Sorry for being in trouble, but can I just try
Yeah,
to...
Sorry, go
Thank
ahead.
you. Alright.
Sorry, what were you saying?
the numbers in the class.
So it starts 0 to the right, 90 degrees to the top, 180, 270.
Okay.
So you can see that. What quadrant will it be in?
So, sine,
Say it again, sorry?
sine positive.
Yeah, and that's why it's giving us minus 5 over 13. How could you use this to get answers for these questions? They want exact values without using the calculator.
Okay, so cos is adjacent over hypotenuse. And then sine is, I don't know. Minus 5 over 13 cos. I don't know.
You will have to draw a triangle.
And then, where does the minus 5 over 13 go?
So let's pick this corner. Okay, so cos you said is adjacent over hypotenuse. What's the adjacent? What's the hypotenuse?
Minus 5?
And so it'll just be 5.
Oh, okay. And 13 is the hypotenuse. Then sine is opposite over hypotenuse, so it would be something over 13.
What is the third side, Saba? You must
Pardon?
calculate. How do you get the third side?
Pythagoras.
Correct.
Oh, yeah. So 13 squared minus 5 squared is 169 minus 25, which is, without a calculator, 169, 164, 144.
Square root
Which is
144? Yeah. Okay, what's sine x?
Opposite over hypotenuse, so 12 over 13.
Sec x?
1 over 1 over, oh, it's just 13, no, it's cos, so it's just minus 13 over 5.
Well done. Cosec x?
13 over 12.
Cot x?
So TOA is opposite over adjacent, so 12, minus 5 over 12.
Minus, okay, so that's tan x, I believe. No, adjacent over opposite is, yeah, 5 over 12. That's it. Brilliant. Any questions there?
Nope.
You did great, Saba. So that's exact trig values. You have to, let me just go back. So write what sine, cos, or tan are equal to as a fraction. So like opposite, adjacent, hypotenuse. Sketch a right angled triangle. Get the third side. And then use that to get everything else. You also need to use your cast diagram to say if it's positive or negative. And in this case, we didn't have to say plus or minus 12 over 13 because we knew exactly which quadrant it was in.
Okay.
Let's see. Yeah, so exact trig values, x a half or tick. Or 3/4.
Yeah.
3/4, okay. Would you like to continue this next time or something else? So continue like year 2 trig?
Yeah, Trig.
Okay, because it's particularly tricky and it'll get much worse.
Oh,
Any questions for me in general?
no.
Okay. Well done, Saba. You're doing great. I look forward to talking again next week.